inverse variation?
No, they didn't.
And if so, write the equation.
Yeah, they're $1,800 and it's like $1,000.
Okay, so here's my table. I have my x values and my y values, and they give them all to me. I have -5, -3, 4, 8, and 24. And they also give me y, which is 2.4, 4, -3, -1.5, sorry, that's getting small, and -0.5. Okay, so I'm going to change colors really quickly. Let's use green, okay? So now, my formula, remember, is y equals a over x. So, what I can do is I can get a by itself. All right, let's do that this time. So, I'm going to take y equals a over x, and I'm going to multiply by x on both sides. Now, why do I do that? Okay, I end up with this answer. Y equals x times y equals a. All right, so what that tells me is if I multiply the x value times the y value, I will get the same number, the same value, a. So every time I multiply an x by a y, I will get a. It will turn out to be the same number, okay? So that will tell me if it's an inverse. So let's talk about that. If I come over here, my equation now is x times y equals a. So that means I can take -5 and I can take 2.4 and multiply them together and get a number. And when I do that, I get -12. Okay? That, for this table, this point I already know is on the graph. All of them are. I just want to know by looking at it and multiplying if it's indirect, if it's an inverse function. So what I'm going to do is multiply all my x and y values. Okay? So I have -3 times 4. That's -12. 4 times -3. That's -12. 8 times -1.5. That's -12. 24 times -1/2 equals -12. Okay, are you seeing this pattern? This is an inverse function because every time I multiply an x by a y, I get the same number, the same value for a, the same constant. If I had something different, like let's say that this point here was actually a 4, okay? When I multiplied 8 times 4, I would get 32. Is 32 the same as -12? No, it's not. So the answer here would be that it's not an inverse function. But of course, that wasn't what I had. I had -1.5. So that's why it works. If I multiply the x value times the y value, I will get the same value, a number. Okay? So this is an inverse function, Now the next question is, that is the only, oh, write the equation, all right? So I got A to be negative 12. So now it's already done, I got it 4 times. So I'm just gonna take my formula and put negative 12 into it. So that is my other answer. Okay, my first answer is that yes, it is an inverse function, and I proved it. And then my second answer is what the equation is right here. Okay, let's go on to number 6. What color were we working with? I think it was purple. Was it? Yeah. Okay, number 6, I'm going to read it out loud and we will write down the important facts. A theater company plans to hire people to bring a stage set. The work time, T, varies inversely, so time varies inversely. That's important. It tells me I have an inverse function with the number of people hired to do the job. Okay? So the company estimates that 25 people working for 300 hours can complete the job. Find the work time per person if the company hires 30 people. Okay, so find the work time, that would be T, if the company hires 30 people. Okay, so let's talk about this. The first thing we know is that time varies inversely, which means, let's think about that. You need less people, or you're going to have less time if you have more people doing something. So let's say you're cleaning your house. If you have 2 people cleaning the house, that takes a lot longer than if you have 5 people cleaning your house. In our way of life, you know, if I'm the only one that cleans the house, it'll take me several hours. When I recruit my whole family, we can get everything done within an hour or 2. It changes everything. So time goes down, people go up, right? As the number of people do something, the amount of time needed to complete the whole job goes down. That's why. All right, so we're using y equals a over x. Varies inversely. So that's the clue, that word that tells me I need that formula. Okay, so I have time that varies with the people. So I'm going to change the number of people, I'm going to call P, and the more people I have, that changes the time. So P, the number of people, is my independent variable, and T is dependent on that. That's the dependent. So that's why T is Y. I'll say that again. I use P for X because that's independent. However many people I pick will directly change how much time I have. So, or how much time it will take. So T changes based on how many people I choose. So T is dependent on the number of people. Okay, so here's my steps. The first thing I'm going to do is write an equation to find A. And the second thing I'm going to do is substitute 30. Okay? So I have my formula, but now I need to use the numbers that were in the problem. So I have up here 300 hours and I have 25 people. So really, do you see, this is not very hard. This is, the whole inverse equation thing is not that difficult at this point because it's direct, okay, or indirect, it's inverse, it's not, there's no y-intercept. So anyway, T is 300 and I don't know A yet, and I know I'm gonna have 25 people. Okay, because that's what they said, 25 people, 300 hours. Now I'm going to solve for A. I'm going to find A. So I multiply both sides by 25, and I get A equals 7,500. So if I know that, then my equation is going to be T equals 7,500 over P. So this is how the time and the number of people will vary. Okay, so I have number one. I solved an equation to find A, and I rewrote it. Now I'm going to do step 2, which is that I'm going to substitute 30 in, 30 people. So I have T equals 7,500 over 30. And if I reduce that, it becomes 250 hours. Okay. So, if you know that with 25 people, it will take 300 hours, but with 30 people, it will take 250 hours. So, you have to decide, do you want to spend the money to save those 50 hours? Okay, what I want you to do is go ahead and try the OIOs number 1, 2, and 3, and we'll come back, pause the video, and we'll come back in just a few minutes. All right, here's our OIOs. The variables x and y vary inversely, and y equals -2 and when x equals 12. Write an inverse equation and find y when x equals -3. Okay, so I start with my formula. I want to solve for A. So I put -2 in here and 12, and now I'm going to multiply, so I get -24. So A is -24. So here is my inverse function, -24 over x. That's my first answer to write the inverse equation. Now I'm going to put x equals -3 in to find y. So I have y equals -24 over -3 and y equals 8. There's my second answer. Okay, number 2. Tell whether the order pairs vary inversely. So here's my order pairs. Okay, and if they do, write an equation. So what I need to do is I need to multiply all of these ordered pairs, x times y, to see if they equal the same thing. So my formula is actually rewritten as x times y equals a. So -5 times 2 is -10. -4 times 2.5, that's also -10. 8 times -1.25, that works out to be -10. Well, we're on a roll here. 20 times, this was negative over here, times -0.5, and I get -10. So all of my constants are the same, so I can say that it does vary inversely. It's an inverse equation. Okay, and I know that A is negative 10, so my equation will be this. All right, the last one is number 3. I'm just going to read it. Suppose the theater company estimates that 20 people working for 270 hours can do the job. Find the work time per person if they hire 30 people. How much time? So I'm really going to do the same thing that I've been doing. So I have y equals a over x, and I'm going to change y to time, and I'm going to change x to the number of people I need to do the job. So I have 270 hours, and I have 20 people. So I'm going to solve for a. To find a, so I can write my equation, and I get 5,400. I'm going really fast with this because I'm assuming you've already tried it, and I'm hoping you have an answer. Okay, so my formula is then going to be, T equals 5,400 over P. So that's my equation. And now I'm going to put 30 people in. How much time is that? So I have 5,400 over 30, and that reduces to 180 hours. That's what it would be. Okay, this was long. You guys did great. We would have done this in an hour and a half at school because it's a very long lesson, this first one. But I will give you the homework, and I hope you have a great Wednesday. Take care.